Thank you very much. Today's topic is going to be OpenStack Trove updates, Juno, Kilo, and beyond. Amrit Kumar from Tora will share what is new in Trove and Juno release, community plans for the Kilo release, and his thoughts on the recent OpenStack Summit in Paris. Amrit is the CTO and founder of Tora, and with that said, let me hand over to you, Amrit. The stage is yours.
Thanks, Raphael, and good afternoon to everybody who's joining us. Thanks for joining this meetup. We're going to be talking about Trove, talking about what's new in Juno, what's coming in Kilo, and as Raphael mentioned, thoughts for people who didn't come to Paris to the summit. My name is Amrit. I'm the CTO of Tora, and if somebody would raise their hand. If they're not able to see the slides now, you should be all set. But if you're not, star 0 for the operator and let us know. Over the next 45 minutes or so, we're going to be talking about Trove. What's Trove, what's new in Juno, and all of those things. A quick summary of these things. If you have questions, ask them using the interface with the web interface, or just tweet the questions to us. The information who to tweet to is on the slide at Tora Corp, #CloudMeetup. And of course, if you have questions later, you can always catch us on IRC or tweet us about those. So without further ado, just in case there are people who are not very familiar with the latest in Trove, what is Trove? Trove is a database as a service project in OpenStack, and the mission statement of Trove is very telling, and there are some words there which are highlighted. Important to remember: scalable, reliable, provisioning, and for those of you who are database geeks, it's relational and non-relational databases, not just SQL, but also NoSQL. And like everything else in OpenStack, it's open source. So it's important to remember that, and the picture below shows you this, if you have a database, it's important to understand that Trove is not the database. Trove is only involved in things like provisioning, deprovisioning, administration, clustering, and things of that kind. Trove itself does not deal with your data. Trove does not touch your data, does not see your data. That's all left up to your application. Your application is in the data plane. Trove is in the management plane only. This is very important for you to remember, especially if you're operating this in a multi-tenant environment. This is very important if you're operating it with secure data and you happen to be using Trove in somebody's service. There are people offering Trove as a service. It's important to understand that the service itself does not get to see your data. That's entirely left up to your application. All Trove does is help you provision, manage, administer, cluster, backup and restore, things of that nature. So Trove is a scalable open source framework for relational and non-relational databases, and it makes it dramatically easier for people to operate databases in the cloud. And it's important to understand a little bit of the architecture of Trove. We're not going to go into the architecture in great detail here. Trove is a project in OpenStack which relies on other services in OpenStack. Core services like Nova, which is compute, Cinder and Swift with our storage, Neutron for networking, Glance for images, and Keystone for identity management. Trove is a consumer of the services of each of those services. So when you, as a user, go to Trove and request a Trove instance, an image from Glance, a Trove image from Glance, is provisioned onto a Nova virtual machine using storage from Cinder. If you happen to be attempting to do backups and restores, you will use Swift. And of course, if you have to contact your database over a network, you're going to be using the services from Neutron. More advanced topologies of databases which have multiple instances, like clustering or replication, would replicate data using Neutron's network. So important to remember that if you're already running the OpenStack services, Nova, Cinder, Swift, the ones at the bottom in the red box, you can use Trove to provision and manage databases using that. Also, a very important thing to remember is Trove, like every other client of these services, uses only the standard documented, well-known interfaces. Trove does not go behind the scenes and interact with any of these services. Identity management is strictly controlled through Keystone, and all access to your virtual machines are through Nova's interface. All access to your data is through Cinder and Swift. Again, very important if you're using Trove in an environment where it's either multi-tenant or where you have data security and privacy issues. So Trove is a service which relies on all of the other OpenStack services. It's important to remember that unlike the other OpenStack projects which we mentioned, Trove is a relatively recent project. So let's quickly talk about the history of Trove. Trove was incubated in Havana, and it was integrated in Icehouse. Icehouse seems like so long ago, but it was just in Atlanta in, I believe, April. But over the last two cycles, Juno and Kilo, participation has grown significantly. We've got almost 128 contributors, almost 130 contributors, almost 30 companies participating, and as of the first of this month, when we counted up the size of the project, it's over 230,000 lines of code. And it's important to also remember that Trove is already operating in production in at least these companies, Rackspace, HP, and eBay. Many others have not publicly disclosed they're using Trove, but I can assure you that many of these are, to use the terminology which somebody used at Summit, companies which my grandmother would know. You're probably going to be surprised if you heard that your bank may be using Trove behind the scenes to operate a lot of things. Trove is very much in operation at scale in a lot of very well-known companies. Also, Trove is a project which came out of work done by Rackspace and HP, and they operate it today in their cloud. And over the last couple of cycles, Tora, which is a company which I helped start, has been a very significant contributor to Trove. In the Kilo cycle, we're a little over a third of the contributions to date, and we were over a quarter of the contributions in Juno. Switching gears a little bit, let's talk about some of the features that Trove provides in a little bit more detail. For background, this is what Trove contained in Icehouse when it came out in Atlanta. Single instance databases with a variety of different data stores, MySQL, Percona, Mongo, Cassandra, and Couch. It supported, like I said, all of the things in the provisioning plane, the management plane, provisioning, resizing, backup and restore, config groups, which allow you to assign groups of configuration parameters to a specific data store and make it easy for you to provision instances for different practical use cases. And of course, it is integrated fully with Horizon, so you can go onto a Horizon console and you can create a Trove instance, you can create a database on a Trove instance, and so on and so forth. It's important to understand that the way in which Trove is architected, it's highly extensible, and while it started off with only these few data stores, it now has several more, which we'll talk about. But one of the consequences of that is that a feature, like backup and restore in this case, when it's introduced, may not be available for every single data store. You may have backup and restore only for MySQL, which was the case in Icehouse, but in Juno, backup and restore is now available for more databases. So Trove is a modular and extensible architecture, and we're adding more data stores and we're adding more capabilities as we go along. So Juno, which just came out in Paris, supports a whole bunch of new features. We extended on the capabilities which were available in Icehouse by adding asynchronous replication or semi-synchronous replication for MySQL. primarily master-slave replication, if for those of you who are familiar with that terminology. This is code which we at Tora contributed to the open source community. We worked with our friends in the community at eBay who contributed all the code for MongoDB sharded clusters. As a community, we worked on several other projects. Our friends at Rackspace contributed basic Postgres support, and we worked on additional capabilities for backups in Cassandra and Couch, and we did a whole bunch of code cleanup targeted at production environments, enterprise environments, and we augmented the testing. So let me pause for a second and talk a little bit about the use cases for Trove with these capabilities. When Trove came out in Icehouse, it was primarily targeted at single instance data stores of a variety of different databases, which are very good if you're doing development or testing kind of use cases. You want to quickly provision a database to do some development as part of some agile methodology, ideally suited to what Trove could provide. We're now adding more enterprise capabilities. Now you have the ability to do read replicas, and you can do read scaling. And we've demonstrated some very good performance numbers with the semi-synchronous replication capabilities. Mongo sharded clusters give you the ability to have some slightly more complex topologies. And we're getting to the point where in the next couple of releases you will see a lot more enterprise capabilities. Those are kind of the trends which you're seeing. But in terms of use cases, Icehouse was good for dev test use cases. Juno is already good for production use cases. And as I mentioned before, Trove is already in production at a couple of places. So let's take a slightly deeper look at how some of this works. If you're familiar with the way in which Trove works, say in Icehouse, you would say Trove create. You provided a name, a flavor ID, and a size. And if the instance which you were creating was a MySQL data store, you would get a single instance of MySQL. Now in Juno, you have the new command line option shown here in red, -- replica. And the way in which this would work is you would create a first instance of MySQL, and then you could create a second instance and indicate that it was a replica of the first. And of course, once you have a replicated pair or any number of replicas, you can update an instance and detach the replica source. So I could create a primary instance. I could create some number of slaves. Then I could go to one of the slaves and detach the replica source, and I would be left with a free-running instance at that point. This is capability which is now available in Juno. And this is currently using MySQL's native semi-synchronous replication. Again, an important thing to understand, Trove is not the database. If you've already used MySQL, and MySQL's been in production for several years, the replication capability which you're using is standard MySQL replication, and therefore it's got all the hundreds of millions of hours of runtime of MySQL replication. It's not as if this is some brand new replication thing which could potentially lead to data loss. Your data is still secure because MySQL is still the database under the covers. And working with our friends from eBay who contributed MongoDB clustering, you could issue a single command, Trove cluster create, and provided the data store, which would in this case be MongoDB, and the version, and this would automatically create a sharded MongoDB cluster. It would provision a config server, a query router, and 3 shards, and later you can add more shards using the Trove add shard command. But effectively, this is the first implementation or first practical implementation of an API which we discussed about 6 months ago, which was the Trove clustering API, and we'll talk some more about other extensions which we plan to have with this API in coming releases. Similar to the replication API where we had adding a replica source, in future releases we will be extending on that API for other data stores as well. So switching gears again a little, that's what we did in Juno. Now what's going to come out in Kilo? And this is some of the conversations which we had while we were in Paris with the Trove development team. We're going to extend on the clustering API and provide support for MySQL Galera clusters. For those of you who are familiar with MySQL, this is synchronous replication. This is also the basis of such replication topologies as Percona ExtraDB cluster. Currently in Juno, while we have replication and its read replicas, there's no automated failover. So in Kilo, we'll be supporting automated failover. Those of you who were in Paris, you probably attended the presentation by a couple of folks from HP who demonstrated how with the capabilities that are currently available in Juno, you can already do automatic failover. And for those of you who are there, you recall that the way in which we triggered the failover was by getting enough people to tweet that the cluster should be failed. The capabilities exist, but we're going to make it much easier for you to use them in Kilo. There are going to be many improvements to usability, things like how you can access log files through an API, how you can associate flavors with data stores. The theme for these kinds of changes and some others are to make Kilo, Trove and Kilo much more secure and much more enterprise friendly. I talked about Trove being secure. In the current implementations of Trove, there are occasions when you may need to log in to the Trove instance at the shell level. Remember, the Trove instance is still a Nova instance, and you may need to do some operations there. We're working with our friends in various database communities, like people at Percona for MySQL, and people at other database vendors like Mongo and DataStax to try and make changes to the underlying data stores to make it easier for them to be usable in Trove. So you'll see some more of those coming out in Kilo. And we've had a lot of companies who have stepped up and offered to put their databases in Trove. You can see some of the names there, DB2 and Couch, IBM was there. Clustering from Cassandra, which we're working on, and so on. We'll talk some more about that in the next couple of slides. But Kilo is going to be a really exciting release for Trove, and it's probably a great idea to start using it right now because when Kilo comes out, it's going to blow your socks off. And all of this is to another way of saying we're taking a long view on Trove in the community. We believe the database as a service is absolutely an integral part of the cloud. It makes it simple, efficient, and cost-effective for you to run an application in the cloud. And an integral part of running an application in the cloud is to be able to run your databases efficiently. And that's basically what Trove does for you. So Trove only focuses on the database part of it, but I think it's an integral part of being able to run a serious application in the cloud. One of the things which I thought was probably a good idea to give you some of a context of what happened in Paris for those of you who aren't familiar or aren't sure why I'm talking so much about Paris. We just had the OpenStack Summit there. There were over 4,500 people. The attendance at these summits has been doubling every year. And 4,500, I think, at this point, I don't know this for sure, it's the highest attendance at a OpenStack Summit today. And specific to Trove, it was really nice to see people from a whole bunch of companies, Percona, Galera, Oracle, DB2, CouchDB were there from the database side. From the operating systems and distribution side, Red Hat, Canonical, people from Microsoft from support representing Windows were there. And again, I apologize if I missed a couple of companies there. I'm sure I did. And we had a lot of interesting presentations about Trove there as well. Speakers from HP, Percona, and some of my colleagues from Tora were presenters there as well. And the last 3 days of the summit, we had design sessions where the development community for Trove got together and discussed new features in Kilo. We discussed some significant code changes which are currently in flight, which some of them have already merged after the summit. We did some rather long code reviews there, and it's always good to get together with people who you've worked with for over a year, only chatting on IRC or reviewing their codes. It's really good to look them eye to eye and hoist a pint of beer, which is what we did a lot of at Paris. So if you haven't been to an OpenStack Summit, if you haven't been to a mid-cycle meetup, I strongly suggest that you try and make it there. And the next mid-cycle meetup is likely to be in Seattle in February. So if you're so inclined, put it on your calendar right now. I've mentioned Tora a couple of times. Just want to take a second to tell you who we are. It's really simple. We're the Trove company. We are the only company focused solely on Trove. We were the #1 contributor in Juno, and we're so far the #1 contributor in Kilo by a wide margin. We offer a database as a service platform. It's based on Trove, but it's targeted at the enterprise. We give you early access to a lot of new features. Our DBaaS platform, which came out with Icehouse, had support for replication well before it was available to the community in the Juno release. We offer improved packaging. We offer customized guest agents, guest images, which we've tested and certified to a very exacting set of standards. And most importantly, we offer support training and services to you as well. The software is available as a community edition and an enterprise edition, both available for download on our website. If you're interested in Trove, give it a shot. We're the leaders in Trove, and we're happy to help you get your Trove deployment going. I'm starting to see a couple of questions come in, though I didn't see anybody tweet them. If you have questions, start putting them in, and I'll try and start answering them as we go along. The distributions that we operate with, we only offer Trove, and our Trove distribution works perfectly fine with either the OpenStack code from upstream. We've also tried it with distributions from folks like Mirantis and our friends at Red Hat and a bunch of others. If you're interested in a complete list, or you would like to use our DBaaS platform with some specific distribution I didn't mention, drop me a note, give us a shout, and we'll be happy to tell you what the certification status is for that. Thanks for the question, and the answer about Red Hat and RDO is yes, we've tried it, it works. We're working on a more definitive answer right now. Also, in the same vein, if you're interested in a specific database, which is not listed here, and not listed here, I mean MySQL and Postgres and Cassandra and Couch and things like that, drop me a note, and I'm happy to help you with getting that database supported and going. The last time I did this presentation, somebody asked me if Neo4j was supported. I don't think that person's on here, but we have a version of Neo4j kicking around in our lab right now. So if there's a specific database you're interested in, let us know. And with that, I've come to the end of the stuff I wanted to say. So now it's time for you to ask questions. But as I do that, there's a list of resources here. If you're interested in more information about OpenStack or Trove, check out openstack.org. If you're interested specifically in Trove, check out our website. We have a lot of useful information and white papers and resources on our blog. And you can also download software there for free. And contact us if you have more questions. And if you're not familiar with how to contact the Trove community, we do most everything on IRC. So on IRC, we're either at #OpenStackTrove or #Tora. So there's a question here. What does it mean to say that companies are offering to put their databases into Trove? So great question. In order to run in Trove, there are a couple of things which you need to do. The first of them is that Trove needs to understand, how to provision, manage, and operate a particular database. For example, if you wanted to run a MySQL database, then the way in which Trove does that is by spinning up a guest image which happens to have a MySQL database installed on it. And on that image, there is a guest agent which does the bidding of Trove. So while different databases have different ways of doing things, Trove needs to provide a common abstraction to all of these. And the way in which it does this is by having a customized guest agent for each database, which is part of that guest image. So when a company offers to put their database in Trove, it means a couple of things. First, it means the company needs to be able to provide a version of their software which can be freely downloaded and distributed as part of a guest image. The second is somebody, and at Tora we're doing this for several people right now, needs to write a guest agent for that database. I mentioned Neo4j. So if somebody wants Neo4j, you need to spin up an instance with with some suitable operating system, put Neo4j on it, and write a guest agent which will provide the Trove abstractions for Neo4j. That is a very quick summary of the kinds of things one would have to do in order to get a database to run in Trove. And then there's the issue of testing and certifying it, and then making sure that all of the APIs work the way in which you expect. And those are some of the things which we do when we put a database in and make it available as part of Trove. There's another question here, and by the way, to the person who asked the question about what does it mean to offer a database in Trove, let me know if you'd like some more details. Another question: are there any particular areas of development for Trove the team is looking for assistance with? Excellent question. There are tons of things where we would like help. If you're not familiar with the OpenStack development process, go to launchpad.net/Trove and look at the blueprint section. There's a whole set of blueprints which have been proposed. A blueprint is basically an idea for a feature. Some blueprints have owners assigned. Several blueprints do not. If you're interested in contributing to the project, one way to do it is to contribute a blueprint with an idea. Another is to pick up an idea and implement it. A third is to download the software, try it out, and if you find a problem, report a bug. Another way in which you can help is if you do something and you find the documentation is insufficient, send us your notes of what you did, and we'll turn it into documentation. We have a full-time tech writer who is working on getting good documentation to make it easier for you to use Trove. Contribution to Trove is not just in writing code. There's a ton of ways in which you can contribute. Try the software out. Use it. Provide a list of bugs. Provide a list of features you'd like. All of those are most welcome. We have 130 or so contributors from 30 companies. We'd love to have more. I'm one of the core reviewers in Trove. We'd love to have people come in and just review code, look at other people's implementations, and say you like it or you don't. Those are all ways in which you can contribute. If you want more details about that, my email address is right here. Send me an email or contact me on IRC. Happy to help you with that. Let me see. Another question here. You provided a guest image with MongoDB installed. How do you get support from MongoDB? What if Mongo needs to send me a hotfix? Excellent question. Okay, so if we provide you with a guest image for a particular database, we're doing it in a configuration which is supported by that particular vendor. As an example, we're working on a guest support for some database. We're going to provide it to you in an environment which is on the list of supported environments by that user. If we have a partnership with that manufacturer of the database, we will make sure that we certify this in a way in which you will be able to get support from them. Now, suppose Mongo, in this particular question, releases a hotfix. We'll provide you a new guest image which has that hotfix installed, and you will be able to upgrade it exactly the same way as you would if you were running Mongo in your own instance. So there's a bunch of details about how you would do it with Trove. There are some rough edges right now. I'll be perfectly honest with you about that. And try it out. In the case of Mongo, it does work, so try it out. Follow on to that, what do you do if you don't have a partnership with the database provider? We currently have partnerships with all the database providers which I listed, and part of our value prop is to leverage those partnerships. So as a company which is solely focused on making Trove available, we're in a position where we spend our time trying to partner with every one of the database vendors who are mentioned here. And we have a good working relationship with each of them. For those of you, as a practical example of that, and also to plug one of our partners, Percona Live is a MySQL conference in California every year. We're going to be doing a bunch of presentations at Percona Live talking about OpenStack and how Percona and Tora work together. We're good partners with them, and we'll be providing a lot of useful content for anybody who's interested in using Trove with Percona there. So that's how we try to make it easier for you to use Trove. Okay, let's look for another question. Great answer. Thank you. What are some of the big areas for Kilo that are planned in Trove? Okay, let me just scroll back to that slide and put it up there. What's planned for Kilo? So to the person who asked the question about Kilo, you should be able to see the slide now. The big areas which we're targeting for Kilo are enterprise readiness features, Galera cluster for clustering. By the way, that's Percona XRDB cluster under the covers. Automatic failover. I recognize the person who asked the question. He was in Paris, and I'm not sure the presentation I'm talking about here, automatic failover and support for MySQL replication. This was the presentation by the two folks from HP. There's a bunch of usability improvements. There's a bunch of new blueprints I mentioned here, DB2, CouchDB, Cassandra clustering, and further testing improvements. So that's kind of the focus. And this content, by the way, came off a slide which was presented by the Trove PTL. So you have it on his word that this is what Kilo is going to be including. Let me scroll back and look for more questions, but if you have another question, toss it in there now. Okay, how do I scroll up and find more questions? Where do I get more information about Trove? Okay, so I scroll back to the right slide here. If you're familiar with IRC, OpenStack Trove is the IRC channel where we all hang out. If you want to get anybody from Tora, we're on #Tora. If nothing else, my email address is on here. I check that pretty often. Other questions?
I went through all the questions while you were presenting, Amrit, so I think that you answered all the questions that came in. So thank you very much for the presentation. The slides as well as the recorded session will be available shortly. And please stay tuned for upcoming sessions. We're going to have a few more with Tora over the course of the next 4 to 5 months. And again, thank you very much, Amrit, for your presentation, and thank you everybody for attending us. See you next time.
Thank you very much.